All right, guys, Wednesday morning, back for another day. Let's see, what did we finish up yesterday dealing with the Pythagorean identities, which obviously are about as important as they get in mathematics. Today we want to take a look at the difference between even and odd functions. You may have talked about this in Algebra 2. If some of you remember it, that's awesome. If you don't remember it, that's okay too. This comes up every now and then, okay, in trigonometry. Doesn't come up, regularly, certainly not as important as the Pythagorean identities. Okay, so the difference between an odd and even function, okay, and I'll give you an example of what this actually means. An even function, okay, for instance, f of x equals x squared would end up being an even function. Okay, because notice what's going on. They're saying that if you take an x and its opposite and you evaluate, you get the exact same thing. Okay, so for instance, let's suppose we use x equals 2. Okay, so we notice that f of 2 gives us 4, but we also noted that f of negative 2 gives us 4 as well. Okay, so we get f of a pair of opposite gives us the exact same value, y value. Okay, that's what happens in an even function. Okay, an odd function, yeah, I'm saying odd function, I'm writing an E for even. Okay, an odd function, okay, would be something like f of x equals x cubed. Okay, because okay, if I take any value whatsoever, like x equals 2, okay, notice that f of the opposite of that ends up being the same as the opposite of f of 2. Okay, f of negative 2, okay, this would be negative 8 right here. Okay, and the opposite of f of 2 would be the opposite of 8. Okay, and so notice what happens is the y value for the opposite of number is the same as the opposite of the y value of the number. Okay, and so you get an odd function. Also notice, and obviously I chose these two examples for a reason, notice that in this case, notice the exponent of this function is even, and therefore we get an even function. The exponent of this function is odd, therefore we get an odd function. Okay. But even in odd functions, they can be attached to whatever different types of functions you're working with, not necessarily just polynomial functions. Okay, it works with trigonometric functions as well. Okay, so let's see. Let's consider what happens when we work with sine and its reciprocal, cosecant. Okay, so this is where this unit circle comes into play. Okay, so you definitely want to make sure you have that close by. Okay, so remember on the unit circle, every point, okay, has coordinates cosine theta, sine theta. So the sine, okay, is the y coordinate. So if we look at sine of pi over 4, well, that'd be right here, the y coordinate, radical 2 over 2. Okay, and then if I take the opposite of pi over 4, so I'll go negative pi over 4, and I take the sine, okay, notice I would be going down here into quadrant 4. Okay, I'd be pi over 4 radians clockwise. So that would take me down to 7 pi over 4, and notice the y coordinate is negative. Okay, negative radical 2 over 2. Okay, so notice how these two y values, okay, are not the same. Okay, so if I take the sine of pi over 4 and the sine of negative pi over 4, okay, notice that I get opposites of each other. Therefore, it certainly appears that sine is odd. Okay, all right, so if I look at the reciprocal, okay, remember the cosecant is the reciprocal of sine, so this would be the reciprocal of this guy. So I would get 2 over radical 2, which obviously is 2 radical 2 over 2, which just gives us radical 2. okay, and then the cosecant, okay, would be the reciprocal here, so I'd get negative 2 over radical 2, which gives me negative 2 radical 2 over 2, which gives me the opposite of radical 2. So notice again, if the sine is an odd function, then its reciprocal has to be odd as well, okay? So odd, no big deal. Now, it doesn't matter whether you're working with radians or degrees, okay? It's going to give you the same results if you're trying to figure out, is it odd, is it even? Okay, so if we look at the sine of 30 degrees and the sine of negative 30 degrees, okay, so here we go, 30 degrees right here, same as pi over 6, so the sine would be 1/2 the y coordinate. And then if we look at the sine of negative 30 degrees, that would take me down here to 330 degrees, going 30 clockwise. Notice the sine is negative 1/2. Okay, so again, if I take the sine of two opposites, the y values are opposites of each other. So again, that means I have to have an odd function. Okay, and obviously cosecant of 30 and cosecant of negative 30 would be the reciprocals here. So I would get 2 over 1 or 2, and negative 2 over 1 or negative 2. So again, odd. Okay, so if a function is odd, its reciprocal has to be odd as well. Okay, so we know that sine and cosecant are both odd functions. Okay? All right, let's take a look at cosine. Okay. I stayed with the same x values here just to make it easy. You could change it to different x values, it wouldn't make any difference. So let's look at cosine of pi over 4 and cosine of negative pi over 4. Now remember, on the unit circle, cosine is your x coordinate. Okay, so the cosine of pi over 4 is radical 2 over 2. And then if I do the cosine of negative pi over 4, that means I'd have to move pi over 4 clockwise. And notice the x-coordinate is still radical 2 over 2. Okay, so notice if I take the cosine of a pair of opposites, the y values are the same. So that means that cosine has to be an even function. Okay, well, if we're going to look at cosine, we got to look at its reciprocal function, secant. So the secant of pi over 4 would just be the reciprocal of this guy. So we'd get we'd get radical, take that back, we get 2 over radical 2. I'm sorry, guys. Which we know once we rationalize and reduce, we get radical 2. Okay, and again, secant of negative pi over 4 would be the reciprocal here. So again, we get 2 over radical 2, and we rationalize and reduce, we know we're going to get radical 2. Okay, so again, the secant of a pair of opposites gives you the same y value. So again, even. Okay, once again, it doesn't matter whether you're working with radians or degrees. If we do the cosine of 30 and the cosine of negative 30, again, cosine of 30 would be radical 3 over 2. And the cosine of negative 30 would be down here, still radical 3 over 2. Okay, so again, okay, even though we switch from radians to degrees, it doesn't make any difference. Notice if you take the cosine of a pair of opposites, you get the same y value. Okay, so it has to be even. Okay. Secant, the reciprocal of cosine. Okay, so if I take the secant of 30 and the secant of negative 30, I just have to work with the reciprocals here. So I get 2 over radical 3, which would give me 2 radical 3 over 3. And same thing here, 2 over radical 3. So I'm going to get 2 radical 3 over 3. So again, the secant of a pair of opposites gives you the exact same value. Okay, so we know that this is even. Okay, so we have figured out so far that sine is odd, therefore its reciprocal cosecant, okay, is odd. Okay, cosine is even, and therefore its reciprocal secant is even. Now we just have to take a look at, okay, tangent and cotangent. Let's see what happens here. Okay, again, staying with the same x values, tangent of pi over 4. Okay, so remember tangent again, when we do tangent, okay, you've got to go sine over cosine. Okay, so on the unit circle, okay, that would be my y coordinate over my x coordinate. Okay, so we do tangent of pi over 4. Okay, I go y over x, and notice I get 1. Okay, so the tangent of pi over 4 is 1. Tangent of negative pi over 4, I go down here. So notice when I go y over x, I get negative 1. Okay, so this is like sine, okay, where if I take the tangent of a pair of opposites, the y values are a pair of opposites, okay, so this has to be odd. Okay, well, cotangent is the reciprocal of tangent, okay, so cotangent of pi over 4 would be the reciprocal of 1, which is 1. Cotangent of negative pi over 4 would be the reciprocal of negative 1, which is negative 1. So once again, we get an odd function. Okay? You take the cotangent of a pair of opposites, and we get y values that are opposites. Okay? All right. Same thing works down here with degrees. Okay? So if we do tangent of 30 and negative 30, okay, so let's see. Tangent of 30 would be y over x. Okay? So we're going to get 1/2 over radical 3 over 2, okay, which would end up giving us 1 over radical 3, which is the same as radical 3 over 3. Okay, so we go the tangent of negative 30, that'd be down here. Okay, so we're going to get negative 1/2 all over radical 3 over 2. So if I reduce it the same way, I'm going to get the opposite of radical 3 over 3. So notice again, tangent of a pair of opposites gives me y values that are opposites. Okay, so that is an odd function. Okay, no big deal. Okay, so let's see. Cotangent, well, would be the reciprocal of the tangent. So the easiest way to take the reciprocal would be to go right here. Take the reciprocal of this guy, so I just get radical 3. Okay, and the only thing that'll change here, okay, because notice right here I would have an intermediary step, which would be negative 1 over radical 3, so I get negative radical 3. So again, it shows us that cotangent is odd. Okay, so it looks like most of these trig functions are odd. Okay, and this stuff, let's see, do we have it on this sheet or not? Yes, we do. Okay, we have this stuff right over here. Okay, so it's on there. Okay, I also have this guy. It's in your notes. Okay, so the easiest way to remember this, and you might want to make a little note of it, okay, the only even functions are cosine, okay, and its reciprocal, secant, okay. Odd functions, everything else. I know that's how I remember. Okay, all I do is remember cosine is the only even function. Okay, therefore its reciprocal is even, everything else is odd. Okay, to me this is the easiest way to remember things. Okay, so you might want to make a little note there on that. Okay guys, that wraps it up for today. Pretty quick one, okay, and that's okay. I have got to put the weekly quiz together today. That'll be posted. You guys stay safe, and I miss you a whole bunch.